Have you ever been in a canoe paddling towards a destination on a windy day? You want to take your canoe and you want to paddle it straight towards your destination, but that pesky wind crops up and keep pushing you off course. What you've experienced is a very simple form of multiple vectors here. What your goal is, as you're trying to maneuver your canoe towards the island, you're trying to go in a direction that's something like this. But you end up having a wind that is trying to push you more like this. So what you end up with is what we refer to commonly as vector addition. So how does vector addition actually take place? Well, let's say I have two vectors here. I'm going to represent vector u as being equal to u1 comma u2. Vector v then is going to be v1 comma v2. So how do I take these two vectors and actually add them together? Well, it's not too dissimilar from addition that you're used to doing. If I take u and add it to v, I'm going to end up with a vector where the components are added together. So it would be you would have a composite vector, then u plus v is going to be u1 plus v1, and the second component then is going to be u2 plus v2. So if I can add two vectors together, a question that might come to mind is for me to multiply something times a vector. And we call that scalar multiplication. So if I have some kind of a constant, we'll call that constant k, and I've got a vector u, and in this case vector u is going to be equal to u1 comma u2, and I take some constant k and multiply it times the vector. Okay, so what do I end up with? I'm going to have k times the vector and I can take that constant then and I can actually use kind of a distributive property. So I end up with k times u1 and k times u2, and we call that scalar multiplication. So I've taken some constant and multiplied it by a vector, thereby increasing its magnitude. So there you have it. We've got the two different types of operations that we do with vectors, vector addition and scalar multiplication. Thanks for tuning in, guys, and you have yourself a good day.